Uh, I think it was here. Right. Two oxides of a metal contain 27.6% and 30%. And this is something I have explained in detail in the previous class also. Try to understand
Yes.
what is given. Uh, the oxides of a metal contain these many oxygen. So these are percentages of oxygen. And suppose the atomic mass of the metal is X, then molar mass will be 3x plus 4 into 16. This will be the molar mass. These many grams you can say. Okay. So what you need to do from here, you can calculate mass of metal or mass of oxygen also. Percentage mass of oxygen is equal to mass of oxygen divided by molar mass into 100. You need to remember this formula. Okay. Uh,
Excuse me, sir.
yes, this formula.
Sir, in this formula, sir, yesterday you said atomic mass,
That
but
is atomic
afterward,
mass actually.
yes, sir.
Understand,
But,
understand.
but
If we
sir, we
consider
take it
one,
in grams,
yes, you're right.
considering. So,
Understand what
sir,
I'm
can
explaining.
we say that molar mass of oxygen upon molar
Yes,
mass of the whole compound
yes,
into
exactly.
100?
That's what I'm coming to. Okay. It is what you say mass of oxygen divided by mass of compound. If we don't consider the chemistry, the mass percent will be mass of oxygen divided by mass of compound into 100. But suppose we assume we have 1 mole, and I am just giving you example, 1 mole of CO2. Then 1 mole of CO2 will have 12 grams of carbon and 2 into 16, 32 grams of oxygen. Total will be 44 grams. And in this formula, mass of oxygen you will substitute as 32, mass of compound you will substitute as 44. And these will be in grams in this formula. So why I am writing mass of oxygen and not molar mass of oxygen? Because there can be more than one oxygen also. Are you getting it?
Yes, sir.
Yes, sir.
Because here this is not only one, it is 32. If you consider atomic mass, you will certainly be writing 16 only. You can't write anything else. So that's why I prefer writing mass, because it will be atomic mass multiplied by how many oxygens are there. Clear? If that is clear, then we can move forward. So it will be mass of oxygen divided by mass of compound, and certainly we are considering 1 mole. Okay? So whenever we are applying this formula, this is something hidden you need to remember. We are talking about 1 mole of compound. In 1 mole of compound, percentage mass of oxygen will be mass of oxygen divided by mass of compound into 100. Mass of oxygen is given, okay, this one. This thing you can calculate. In first compound, it is 27.6. Mass of oxygen here is 3x plus 64. In 1 mole, oxygen is 64. Divided by total is 3x plus 64. Simplify this one. From here, you will get x equals to approximately 56. Why I have written 64? Because atomic mass I have considered x, but there are three, three atoms of metal, so that's why 3x. Compare it with CO2. Atomic mass of oxygen 16, but there are two. That's why I considered 32. So same here. Now this 56 I'll use in second one. In second case, it is 30% oxygen. So metal versus oxygen will be 70%, 30%. Means if I'm considering, now I'm considering this case, second case. Oxygen is 70%. So metal will be, sorry, oxygen is 30%, metal will be 70, oxygen 30. If I have 100 gram of the sample, metal will be 70 gram and oxygen will be 30 gram. And now remember, all the formulas are nothing but their molar ratios of atomic masses. For example, if I say CH4, it means I have one atom of carbon, four atoms of hydrogen in one molecule of methane. If I multiply both by Na, I can do, because I am multiplying by same number, then it will be 1 mole, this will be 4 mole. So it means it is either you call atomic ratio or you call molar ratio. In any formula, the representation is nothing but their molar ratio. How many moles are there? So I can say 1 mole of carbon, then 4 moles of hydrogen will be there. Keeping this concept in mind, if I calculate the number of moles of metal and number of moles of oxygen, their ratio will give me the formula. And moles I can calculate very easily because I know moles are given mass upon atomic mass. Atomic
Yes.
mass of metal is 56, I have calculated. Given mass divided by atomic mass of oxygen. This will give me the molar ratio. And if you simplify this, you will get it as 2:3. It means the formula of the compound will be M2O3. Is that clear? Or if there is any
Yes, sir.
confusion, let me know. Devanshi, is that clear? I think probably you asked that.
Yes, sir, clear.
Okay. Next topic.
So,
Yes.
sir, I wanted to ask the last question of the assignment.
Mm-hmm.
Laws of reciprocal combination.
Mm-hmm.
So, वो पूछना था सर वो नहीं आया.
Have
Sir,
you gone through the video?
can I
Till ninth
clarify this
actually.
one thing
Class?
about the same concept?
Mm-hmm.
Sir,
Come
in
again.
law of reciprocal, sir, yesterday when you were doing the questions, I noted your solution. Sir, I guess you fixed S or sir one of the atoms. Sir, but can we fix any atom on ourselves and consider the other two, or it will be decided according to the given data in the question?
In reciprocal proportions, you don't have any choice. You will fix that one which is same. For example, H2O and H2S. You have to fix only
Yes.
H2 because hydrogen is common. You can't fix sulfur and oxygen.
Yes, sir, only one thing needs to be fixed. But sir, is that on what criteria can we decide it, or like
The
is it on the
criteria is
basis of
which one is
question?
common.
Okay, sir.
What I mean to
Okay, sir.
say, in example, if you remember, we considered H2O, H2S, and SO2,
SO2. Yes.
right?
Yes,
So
sir.
if you
Yes.
are considering these two, you will fix hydrogen as 1 gram.
Yes, sir.
Okay.
Then find the sir mass of the other two elements S and O.
Yes. Then so you will fix these as 1 gram
Yes,
and
sir.
find the ratio here.
Ratio of the masses, and sir in
And
SO2 we can find the
ratio
ratio
here.
easily.
The ratio of these two ratios will be simple whole ratio.
Yes, sir. Multiple for. Okay, sir.
Okay.
Yes, sir.
Now suppose you consider same thing. H2S, H2O, SO2. But you consider these two. In these two, what is common? Sulfur is common. So
Yes,
you
sir.
will make sulfur as 1 gram
Yes, sir. And
and
find O and
calculate the
H2.
ratio of
O2 and
hydrogen
H2.
and oxygen.
Yes, sir.
And you will compare that with ratio of hydrogen and oxygen here.
So in
Their
water.
ratio will be
Yes.
simple whole ratio.
Okay, sir.
Now next topic. And make sure that you go through the video recordings, and that will actually help you to retain it in your memory and to understand it, strengthen the concepts. Only 2 students have gone through the recording. Stoichiometry and stoichiometric calculations, the This is actually a jargon for simple hole ratio again. That the reactions in chemistry happen in simple molar ratio. This is another word for that, stoichiometry. What I mean by that? Stoichiometry deals with the calculation of masses, sometimes volumes also, of the reactants and products involved in a chemical reaction. These are done with the balanced chemical equation of a given reaction, but these have to be in molar ratio. I'll tell you why. How? Suppose this is the balanced equation. We will be using this equation in one of the questions. Pratyush, you say, sir, it is important in every question of law of reciprocal that ratio of one is to be multiple of the other ratio. Yes, ratios will be multiple in case of reciprocal. So it is different from law of multiple proportions. In reciprocal proportion, this is comparison of the ratios.
So,
Yes,
sir, in reciprocal combination, sir, is it necessary for the ratio to be whole number?
yes, it is.
Okay.
That's the law is. Basically, if you remember the diagram I had shown just when I consider H2S, H2O, and SO2, that which you need to fix and which ratios you have to compare, that is diagrammatical representation of reciprocal proportions law.
Okay, sir.
Sir, in reciprocal proportion, the ratios can't be same, or they have to be same in
They
some
can be
cases.
same. They can be same. Then in that case, the ratio will be 1:1. There is
Okay,
no
sir.
restriction that it can't be 1:1. 1:1
So
is
either
also a
ways, it
simple
is a
whole ratio.
multiple only, sir.
Yes, yes. Okay. It will be simple whole ratio. Whether it is 1:1, 1:2, 3:4, doesn't matter. It can be 1:1. So if we consider balanced equation of the reaction of methane with oxygen, in this case, it simply means that there are various ways to look onto this particular reaction. First, we need to understand. Samad, I'll show the definition of. Do you mean definition of reciprocal proportions or definition of stoichiometry? Samad. Definition. Okay, definition. You don't need to remember. No, nobody is going to ask what is stoichiometry. Right? Define stoichiometry. Okay? And you will anyway be able to write it once I explain it. So first understand, you will be able to write it. In this reaction, we are saying that coefficients 2 of O2, that is here, and H2O, these are called stoichiometric coefficient. So that's why I said this is just a buzzword, nothing else. It is just telling me that there are, if this is we are considering in moles, there are 2 moles of oxygen, 2 moles of H2O are produced. 2 moles of oxygen are used and 2 moles of steam will be produced in simple terms. Similarly, there is a hidden one we don't write here. 1 mole of CH4 will be used in this reaction and 1 mole of carbon dioxide will be produced. So essentially what we are saying here, we are saying if we get 1 mole of methane and 2 moles of oxygen reacted, and when they are completely consumed, remember initially I am saying I have 1 mole of methane and 2 moles of oxygen. And these will be 1 and 2 moles when I don't have the products, means reaction has not started. But when reaction is completed, then 1 mole of carbon dioxide and 2 moles of steam will be produced. So you need to represent or understand this reaction in this way.
Sir, which coefficient do we need to look at? So like in 2O2, which two are we supposed to consider? Sir, that I'm
Which I
unable
am
to
which I
understand.
am encircling, which I am
Okay,
encircling.
sir. Oh, okay, sir.
Those ones.
Okay.
This tells you that this is O2 molecule. We don't have anything to do. We can't separate O and O here.
Yes, sir.
We have oxygen gas. We will get O2. We will use it. Similarly, in
Sir, can
C,
you please explain it again?
yes, you will understand. I'm explaining again, okay, with all the steps. So they represent the number of molecules and moles as well, because you will get number of moles if you multiply molecules by Na. So molar ratio will be same as molecular ratio, which are taking part in the reaction or are being formed in the reaction. What I am saying that whatever is the coefficient here it is hidden 1, it is 2, it is hidden 1, it is 2. So it says 1, 2, 1, 2 in this particular reaction. These can be different, right? Depending on reaction. It says if 1 mole of methane is reacted with 2 moles of oxygen and they are consumed completely, means nothing is left, then 1 mole of carbon dioxide and 2 moles of steam will be produced. In simple terms, I am taking another example so that you can understand. And that is very common example normally. Nitrogen and hydrogen combine and they produce ammonia. In this reaction, it says when 1 mole of nitrogen is reacted with 3 moles of hydrogen, then when they are consumed completely, then 2 moles of ammonia will be produced. Before reaction starts, after reaction is completed. Is that clear now?
Yes, sir.
You just need to see coefficients as moles used and moles produced.
Sir, when do we consider the coefficients of one and when zero? So like, what is the difference?
Zero, what do you mean? Okay, I'll
Sir,
explain. Okay.
sir, here you have written before, after. I'm getting confused in this part, sir.
Before means the reaction has not started. Before reaction starts. After reaction is finished. When reaction is finished, then these two will have reacted. These will not be present,
Yes, sir. Yes, sir. In
right? So
existence.
that's why their moles are zero.
Okay, sir. Okay, sir.
Initially, these were not reacting. There was no product at all because there was no reaction. So that's why ammonia was zero. So coefficients you just need to consider moles used and moles produced. In gaseous form, this will again be the volume also because moles are proportional to the volume. You know the ratio. Okay, volume at STP is equal to 22.4 multiplied by number of moles. It means if you remove this constant, volume will be proportional to moles. Clear? Volume
Yes,
in
sir.
gaseous
Yes, sir.
form will be proportional to moles. So if the ratio of moles is 2 is to 3 is to 2, sorry, 1 is to 3 is to 2, and 2 plus 3H2, then combine will give you 2NH3. So if this is the molar ratio, same will be the volumetric ratio.
Sir,
Because
can the
volume,
number of molecules be same in reactants and products as well?
yeah, there is no restriction on that. Okay.
Okay, sir.
This reaction, this will also be same because if you consider the volume, it will be 1 into 22.4 at STP, 3 into 22.4, 2 into 22.4. These will get cancelled. Ratio you will get same. That is, if 1 mole of nitrogen and 3 moles of hydrogen are reacted, when they consume completely, they will produce 2 moles of ammonia. When 1 volume of nitrogen and 3 volumes of hydrogen are reacted, and when they are consumed completely, they will produce 2 volumes of ammonia. That is what we call stoichiometric calculations, means in their molar ratio in balanced chemical reaction. That is called stoichiometric calculation. Is that clear? What is the
So
stoichiometry?
what is the application of this, sir,
This is
stoichiometric calculation?
application is you will come to know how much ammonia will be produced. Or
Okay, so
if you
just the
have,
volume, sir.
no, you can calculate from moles, you can calculate grams also. If you know the moles,
Yes, sir.
you can
Yes,
calculate
sir. The
grams
grams can
also.
also be
So
calculated.
suppose you are asked that you have been given 28 grams of nitrogen, then calculate how much hydrogen will be required so that it gets reacted completely with that hydrogen, and then calculate how much ammonia will be produced. So this will be required. We will be doing those questions today.
Okay, sir.
And this ratio can be, any ratio, any simple whole ratio. So it can be 1 is to 1 is to 1 is to 1 also. It can be 2 is to 3 is to 4 is to 1 also. There is no restriction. It will be depending on the balanced chemical reaction. Whatever is the balanced chemical reaction, you will just see the coefficients, and those will be the moles. And ratio of those moles will be stoichiometric ratio. Okay, so just repeating the same thing. 1 mole of CH4 reacts with 2 moles of O2 to give 1 mole of CO2 and 2 moles of H. Okay. Or you can say 1 molecule of CH4, because there is a straightforward relationship between mole and molecule. You divide 1 by Na, you get molecule. You divide 2 moles by Na, you get here molecule. Here it is 1 mole divided by Na, 2 moles divided by Na. This will be the molecular ratio. And Na will get cancelled. You will get the same ratio. 1 is to 2 is to 1 is to 2. So whatever is the ratio of 1 mole, that will be of the 1 molecule, that will be of the volume. Okay. So whatever is the coefficient ratio, in this case 1 is to 2 is to 1 is to 2. This is molar ratio as well as molecular ratio as well as volumetric ratio. In this case, it is volumetric ratio because all are gases. Be cautious when there are liquids, solids, or aqueous compounds. In that case, it will not be volumetric ratio. It will still be molar ratio, it will still be molecular ratio, but not the volumetric ratio, because volume conversion from mole is applicable only for gases. You remember that. Okay. So that's why exclude solid ones and liquid ones from volumetric ratio. In that case, this part will not be applicable because you can't convert solids by multiplying 22.4 to numbers or volumes. Then you can say in terms of mass also. For that, understand it. This is 1 mole, 2 moles, 1 mole, this is 2 moles. Now you can convert moles to mass. How the conversion you do? Number of moles multiplied by molar mass. Mass is moles multiplied by molar mass. You remember that conversion, mole to mass.
Yes, sir.
Multiply mole by molar
Molar
mass.
mass.
So that is important. Always, whenever you get time, go through that diagram. So you can convert here moles to, you are calculating mass. So these are moles, and you are getting mass from this. Number of moles multiplied by molar mass. Molar mass of methane is 16, 12 plus 4, 16. Here, mass of oxygen will be 2 moles multiplied by its molar mass, 32. O2 molar mass is 16 into 2, that is 32, multiply by 32. 1 mole molar mass of carbon dioxide, 44. 2 moles multiplied by molar mass of water, 18. It means okay, 16 grams of methane will react with 64 grams of oxygen. And when these are consumed completely, they will produce 44 grams of carbon dioxide and 36 grams of steam. Is it clear what I am saying? I converted moles to masses. So instead of talking in terms of mole, I am now talking in terms of masses. So if you are asked how many grams of carbon dioxide will be produced if you have been given 8 grams of methane. So if you have been given 8 grams of methane, 16 grams produce 44 gram, 8 gram will produce 22 grams. That
22
will be the
grams.
answer.
Yes, sir.
Okay. So that's why it is important. You can be asked in terms of moles, in terms of mass, in terms of volume, in terms of molecules, very rarely. But you know the ratio, you will be able to give the answer.
Sir,
Because
but
you
the
know the
main part is
conversion.
that we need to know the balanced equation, no, sir? If we know that, then we can solve these mass questions, sir.
You are absolutely right. In many cases, you need to remember the reaction. And that's why chemistry is not that easy. Okay. In
Yes,
many
sir.
cases, your teachers will expect you to know the reaction. And the good part is, even though it is slightly difficult, the good part is that it's not out of blue that you get reactions from everywhere. No. Okay? There are certain reactions which you need to remember, and you can memorize those reactions very well. If these are, related to inorganic chemistry, yes, it is slightly difficult because there is no pattern. Most of the reactions you will have to memorize. But in organic chemistry, there is some relief that there are few patterns which you need to remember, and it will take around 50% of time what it will usually take in case of inorganic chemistry. In organic chemistry, it will be easier to memorize the reactions because there is certain pattern. So for example, alcohols, the reaction will be of a specific type. Aldehydes, ketones, there will be reactions of a specific type. However, there are too many reactions, so obviously it will require time, but there is certainly some pattern. Now coming to this point, this reaction, I have a question, and then I'll explain how you can write these type of reaction very easily. And this is the question. Calculate the amount of water in gaseous form produced by the combustion of 16 gram of methane. This is actually the previous reaction. Okay? But you can
Yes, sir.
write combustion reaction of any hydrocarbon. Methane is alkane, type of alkane, but there are alkenes also, alkynes also. You can write, and you need to memorize this right now. Okay, the combustion reaction. So I'm writing it, and you need to write it in your notebook and memorize it today. General or generic combustion reaction of hydrocarbons. Hydrocarbons means alkanes, alkenes, alkynes, means only carbon and hydrogen present there. So that will be,
So hydrocarbon.
yes. So it will be, you write CHY, certain moles of carbon, certain moles of hydrogen. For example, C2H6. This is a hydrocarbon. C2H4, this is a hydrocarbon, but alkene. C2H2 is again a hydrocarbon, but alkyne. X, in this case, X2Y6. In this case, X2Y4. Okay. In this case, x3, y8. So that's how you need to just apply the rule. Plus x plus y by 4 O2 will give you x CO2 plus y by 2 H, all in gaseous form. Okay. This may not be in gaseous form, CXHY, depending on what is the molecular mass. Okay. These you will get in gaseous form. Don't write gaseous form, write the general form. And try to memorize this. You normally won't get written in NCRT. You need to remember this generic equation. Now, if you apply that for CH4, methane, what is X? X is 1, Y is 4. X is 1, which is not written, Y is 4. So write here 1 plus Y is 4 divided by 4 O2 will give you X is 1. So CO2 plus Y is 4 means you will get CH4 plus 1 plus 1, 2 O2 will give you CO2 plus 4 by 2, 2. This is the same reaction if you see. Balanced. So you can get balanced reaction of combustion of any hydrocarbon by using this generic equation.
Sir, is there any like exception to this thing which we might come across?
You can come across because that is, but that is again exception to 11th grade, that will not be asked.
Okay, sir. Okay, sir.
Okay. So you will be asked about combustion of hydrocarbons only. Okay. But there are other compounds of CH which not sometimes do not fall in the category of these, but those are out of scope.
Okay,
For you,
sir.
this will work. You can apply it for, butane, propane, octane, decane, whatever you want. It will be giving you balanced equation.
Excuse me, sir.
Yes.
Sir, I still didn't understand how x plus y by 4 came to be of O2.
Mhm. It is because first you understand what is the value of x and y. Did you get that? 1 and
Yes,
4.
sir. Yes, sir.
Okay. So in place of x, I have substituted 1 because x is 1. In place of y, I have substituted 4. So it is 4 by 4. And 4 divided by 4 will be what? 1. And 1 plus 1 will be what? 2. Did you get that or not?
Sir, I said that how did you get y by 4? Matlab, in that context, it should be x plus y amount of O2. How did you get to know that it should be y by 4 to make it
So
1 or 2?
that is something we have already done, work. You don't need to go into how we got that. Derivation is not in your syllabus. That's what I'm telling you. You need to remember the generic form. It's not about how you get this y by 4. Are you asking how you get this y by 4?
Yes, sir.
No, that's not the in context of what we are doing here. That is mathematics
Okay, sir. Okay.
and not at all in syllabus. Nobody is going to ask you how you got this y by 4 or how you got this y by 2. I'm telling you a balanced equation which you need to remember to get any reaction of combustion of the hydrocarbons.
Okay, sir.
Okay.
So we cannot use this to find moles.
You are actually calculating moles here. When you get the balanced reaction, it will tell you the molar ratio.
Sir, so do we show this or this just for the balanced equation itself?
Just balanced equation. You don't need to write an exam. Okay. This is something, if you are asked that the same question, calculate the amount of water produced by combustion of X grams of pentane. Then how will you write the equation, balanced equation, if you don't know that? Then you will, on rough paper, you will use this generic form and you will get the balanced reaction. You will use that reaction in the question. Did you get what I am saying?
Yes, sir.
I am nothing
Yes, sir.
proving here. I am telling you how to use this reaction, because normally students don't know this, that there is generic reaction from where you can actually get the balanced reaction. Otherwise, you will have to memorize all the balanced reactions of combustion of alkanes or alkenes or alkynes. So this is a trick that you will be using the generic equation to get the balanced equation of combustion of alkanes, alkenes, and alkynes. So for example, if you have pentene, for example, C5H10, pentane will be C5H12, pentene will
H12,
be
sir.
C5,
Oh, okay,
pentene
sir.
I am saying.
Okay, okay, sir.
Pentane will be C5H12, pentene will be C5H10. So even for this one, you can write the reaction, because it will be X plus Y by 4 O2 gives you X CO2 plus Y by 2 H2O. So from here you will get C5H10 plus 20 plus 10, 30 by 4 means 15 by 2, O2 gives you 5 CO2 plus 5 H2O. Now multiply whole by 2, 2C5. Why multiply whole by 2? Because you need to get rid of this denominator. C5H10 plus 15O2 will give you 10 CO2 plus 10 H2O. Otherwise, how can you remember all the balanced reactions? You will not be able to memorize all these reactions.
Yes,
But
sir.
you can certainly memorize one generic reaction for combustion of hydrocarbons. Is that clear?
Yes, sir.
Yeah, so
Sir,
that is
Yes, sir.
actually for usage. You need to use it if you are asked to calculate something to get the reaction. Yes, tell me.
sir, will it work if, sir, sometimes there are fractions like across, like if you assume, sir, that in pentene and all other elements and compounds, sir, there are moles in the form of fraction, and all have different denominators, then, sir, can we proceed without like removing the like denominators from them?
You can, but calculations will be difficult. So that's why it is easier to convert these into integers instead of fractions.
Okay, sir.
Even if you use this one, the ratio is same.
For this one, sir, it's still easy, sir, but
Yeah.
yes, sir.
If you don't remove the denominators, if you still keep it in fraction form, the answer will be same. Only the calculation will be slightly complex.
Okay, sir.
Okay. So, for example, in this question appears and you don't know the reaction, you can use this generic form to get the reaction. And then you can solve as I am going. You will write the reaction. CH4 plus 2O2 will give you CO2 plus 2H2. Okay. Now, first you will write as per the balanced reaction how much quantity will be produced of water if you have 1 mole of CH. So what is the molar ratio? 1 is to 2. Remember, we are talking about only water and methane. The question is talking about calculate the amount of water, gaseous form, produced by combustion of 16 gram of methane. It means you should be interested in ratio of these two. And what is the molar ratio of these two? 1 is to 2. If you have 1 mole of CH4, why 1 mole? Because there is 1 here, which is not written. Then you get 2 moles of water. Now, because we are talking about in terms of mass, convert it to mass. 1 into 16 grams of methane will give me 2 into 18 grams of water, means 16 grams of methane will give me 36 grams of water. And that's what is asked in the question. Question says calculate the amount of water produced by the combustion of 16 grams of methane. So I have written the equation of combustion of methane. Then I found the molar ratio of methane and water. Then I found the mass ratio. Is that clear? Any confusion, let me know.
Yes, sir. One confusion, sir. Here you are using the data of a reactant to find the mass of a product, sir.
Product.
But can
Yes.
we do the same to find the mass of another reactant involved?
Yes, yes, we will be doing that.
Okay, sir.
Every ratio it will be applicable, whether you have this one, this ratio, or this ratio,
So from any
or
one
this
data,
ratio.
we can find all
Any
the
ratio.
other.
Yes.
Okay, sir.
It means if you consider only oxygen and carbon dioxide, means 2 moles of oxygen will produce 1 mole of carbon dioxide in this reaction. Okay. Two
Yes, sir.
moles of oxygen will produce 2 moles of steam. Tell me whether steps are clear or not, because you will, in all such questions, it's simple steps you need to follow. What I am doing again and again, you can see, I am first getting ratio of moles. Then if question will ask me in terms of mass, I change it to mass. If it is to in volume, I'll change moles to volume. If it is in terms of molecules, I'll change moles into molecules. First is molar ratio, which is actually nothing but the stoichiometric ratio, is actually the molar ratio. Next question. How many moles of methane are required to produce 22 grams of CO2 gas after combustion? Again, write the same reaction. CH4 plus 2O2 will give you CO2 plus 2H2. Now it is how many moles of methane, so we need to consider methane,
Sir,
to
so we'll
produce
say 1 mole.
22 grams of carbon dioxide. Now it is moles and mass, but it is again easy. You will first write moles ratio, 1 and 1. What is the molar ratio? 1 is to 1. And in terms of mass, this carbon dioxide will be how much? 1 into 44, that is 44 grams. Is this clear? Up to here,
Yes.
is that clear? Okay. Now, 1 mole produces, 1 mole of methane produces 44 grams, it means. So
Half mole
1 mole
will produce 22
of,
grams.
yes, exactly. So you will write it actually in other way around. You will say 44 grams of CO2 is produced by 1 mole of methane. Hence, 1 gram, I am applying unitary method, 1 by 44 grams of methane. Hence, 22 grams of methane will be produced 1 by 44 into 22, that is 1 by 2, that is 0.5 moles of methane, which is anyway evident. If 44 is produced by 1 mole, then 22 grams, just half, will be produced by 0.5 mole.
Sir, I first calculated the mass of methane, then sir calculated the mole. Sir, is it okay?
That will be lengthy. You don't need to do, because
Okay,
question
sir.
asks in moles to mass, you can directly use mole to mass ratio. 1 mole
Yes, sir.
is
Yes, sir.
required for 22 grams. And normally that will be the approach, and your teacher will be using that approach only. Conversion, everything to mass. And if questions, these questions are just very simple questions. Lengthy questions, 3 marks questions, if you follow that approach, that you convert everything to mass, and then that will be time consuming, a lot of time consuming.
Okay, sir.
Now the limiting reagent, and to understand the limiting reagent concept, you must have understood this concept very clearly, what we discussed here. Okay? If you don't understand this concept clearly, you will face problem in limiting reagent. And that is the reason many students face problem in limiting reagent calculations and numericals. So first understand what is limiting reagent. I won't go through the definition. because definition you can write the moment you understand what limiting reagent is. I start with the example. Suppose I have same CH4 plus 2O2 gives you CO2 plus 2H2O. This balance reaction says that 1 mole of CH4 will react with 2 into 32, that is 2 moles of oxygen. Means 16 grams of methane will react with 2 into 32, 64 grams of oxygen. Moles mass. To convert into mass, you just multiply by molar mass. Oxygen molar mass is 32. 16 into 2 is 32. But suppose instead of 64, you have only 60 grams. You don't have 64 grams. And you get it reacted with 16 grams of methane. In this case, this one will get consumed completely. There will be some amount of methane which will remain unreacted because it is in excess as compared to oxygen. So oxygen in this case will be limiting reagent. Why limiting reagent? Because it limits the reaction. It stopped the reaction. Otherwise, reaction would have continued because CH4 was there. Some CH4 was available, but oxygen was less than required. So that's why it got consumed. When it got consumed, it is not available for the reaction. So no further reaction will take place. So limiting reagent is that one which stops the reaction, limits the reaction, gets consumed completely. These are important points. That's why I am repeating. Limiting reagent is that reactant which limits the reaction, stops the reaction, gets consumed completely, and more importantly, decides the amount of product. This will decide the amount of product because it will stop the reaction. The moment it stops the reaction, product generation will stop. Product will not be produced further.
Sir, I
It
have a
will
doubt, sir. How do
yes.
we know which one is the limiting reagent? Like which one will get consumed completely?
That is
Sir.
something I'll tell you. That is something you need to wait for 5 minutes
Okay, sir.
for that. First, you need to understand what is a limiting reagent. Limiting reagent is that one which is in less than required amount. That one will be the limiting reagent. It will get consumed completely. It will stop the reaction and it will decide how many moles, how many grams of the product will be produced, not the other one. So suppose, for example, I'm just giving you an example so that it is more clear. With the same reaction, required molar ratio is 1 is to 2. Okay. But what you have in question, 1 is to 1. This ratio is given. You have 1 mole of CH4, 1 mole of O2. So in this case, the required was 2, but you have only 1. It will be the limiting reagent. Oxygen will be the limiting reagent. Now you need to find out how much product will be produced. So required ratio was 1 is to 2. This was the required ratio which we talked about. 1 mole of methane will react with 2 moles of oxygen, will produce 1 mole of carbon dioxide and 2 moles of steam. But because we have 1 mole of oxygen, this will decide the product. Means the ratio here, the ratio here will be decided by this. Means the ratio between oxygen and carbon dioxide is 2:1. Means the ratio will be 1:0.5. This is important to understand. Now, not 1 mole of carbon dioxide will be produced, because 1 mole of carbon dioxide would have been produced if there were 2 moles of O2. But we have only 1 mole of O2, that will result in 0.5 moles, half the mole. Here half the mole, here also half the moles. So 0.5 mole of carbon dioxide will be produced, not 1 mole. Means this is not deciding how much carbon dioxide is being produced. Because if we consider CH4, then 1:1 is the ratio. We would have said 1 mole of carbon dioxide will be produced. No. The reason is 0.5 mole of this one will remain unreacted. And pay attention here, why I am saying it will remain unreacted. Because between methane and oxygen, the required ratio is 1:2. If we have only 1 mole here, 0.5 mole will react with it. If there would have been another 1 mole, then 0.5 remaining would react, and then it would have been 1:2. This would have been 1, this would have been 2.
So we can make relation as 1/2 equal to x upon 1 in
Yes,
such case to find
it
the moles.
actually it is, if you can understand the unitary method, which is you are doing from your 6th grade, all these calculations are easy. And that's what I advise, that whenever you have any problem in these calculations, understand the unitary method very clearly, or the direct proportion, again you have been doing from your 7th grade. Okay. So direct proportion is important to understand, and here it is direct proportion. I'm clearing the screen and explaining again for those ones who still are confused. Suppose you have a reaction. I'll take simple reaction, say C plus O2 gives you C. Yeah. Here the ratio required is 1:1. And when this ratio is as per requirement, balanced equation, 1 mole of carbon dioxide will be produced. 1 mole of carbon will react with 1 mole of oxygen, and when they are consumed completely, they will produce 1 mole of carbon dioxide. So this is required as per balanced equation. And in question, suppose you have been given that you have 3 moles of carbon, so say 3 moles of oxygen and 2 moles of carbon. Now I'm making it slightly typical, and if you can understand this one, you will be able to understand how to find the limiting reagent. Basically, now I am telling you how to find the limiting reagent.
Sir, so C will be the limiting agent here because one mole of O2
Yes,
will
it will be. But
left
there is
over.
very easy way in complex reactions, right? Where ratios are say 2:5:3, something like that. What is the way how you can easily find which one is the limiting reagent? Okay, that is something I'm going to tell you. So here ratio is 2:3. Okay, the required ratio is 1:1, but in question, and this is how you will write. You will first write required ratio as per balanced equation. Okay, and this is given in the question. Okay, this is how you will do. And how to calculate which one is the limiting reagent? You will always find Q by R ratio. What is Q by R ratio? whatever is given in the question and what is as per the balanced reaction. So R stands for balanced reaction. Q stands for what is given in the question. So find this ratio. Here it will be 2 by 1. Here it will be 3 by 1. Whichever is less, that will be limiting reagent. The ratio. In this case, because I have here 1:1, obviously it is easy to understand. But I'll explain with other reaction, then it will be clear why I am talking about Q by R ratio. But you don't need to mention this in examination. This is only for your rough calculation. Okay. Your teacher will not be able to understand what you are talking about if you say Q by R ratio is less. In this case, it is limiting reagent. No. Okay. Now, Q by R ratio, if you are clear about it, understand it with a reaction. Suppose I am talking about this reaction only. CH4 plus 2O2 gives you CO2 plus 2H2. The required ratio is 1:2. And suppose given in question, okay, this is given 43, this is given 8. Okay. So calculate Q by R ratio. 43 divided by 1, 80 divided by 2. Which one is less?
Sir, oxygen, sir. It is limiting
This
reagent.
is the limiting reagent. Okay. Calculate Q by R ratio somewhere, on the right hand side and do rough work. Q by R ratio, the one which is less will be limiting reagent. Okay. So that way you don't need to bother about that. You need to first understand, okay, well, these many moles will be consumed of this particular compound, these many moles will be consumed, which one will be? No. Just Q by R ratio, and that's the limiting reagent. The smaller one is the limiting reagent. If you have understood that, this question is actually from NCERT, and I have slightly modified it because in NCERT, this question is written in a way that it doesn't make any sense at few places. You will be able to answer this question to me very easily. It is A plus B2 gives you AB2. Don't answer on the mic, answer in the chat window. I am giving you just hint. Required is 1:1. Okay. Moles, which will be same as moles of atoms and molecules, because these are atoms, these are molecules. So if I say 300 atoms, 200 molecules, it is same as the molar ratio. Now tell me which one is the limiting reagent. Yes, you got it. Arman, Yash, Goyal, Anu, Devanshi, Pratham, Karke, Savya. If I missed your name, write again. Sanskriti, Tanishi, Gyanendra, is correct. Everyone is correct. So how you got it? Because you calculated Q by R ratio. Q by R ratio here is 300 by 1, 200 by 1. This one is less. You said B2 is limiting reagent. Yes, Arjun, it is correct. So in this case, you said B2 is limiting reagent. In first case, B2 is limiting reagent. Now the second one, 2 moles of A, 3 moles of B2. Yes, Ariman, Devyansh, Kartike, Kavish, no, Pratham, think again, Pratham, Kshitij, Arna, Pratyush, Lemuel, Samad, Sanskriti, Savya, Ayush, Devanshi, all correct, right? Because you calculated Q by R ratio. It is, sorry, 1:1 in here, 2:3.
Sir, that is why I wrote none of them. So I was thinking both are same.
Okay. Okay. Yes, I accept the blame. Yes. So Q by R will be 2 by 3 and 3 by, sorry, 2 by 1 and 3 by 1. It means in this case, A will be the limiting reagent. Next, 100 atoms of A and 100 molecules of B2. A plus B2 gives you AB2. 1:1 is required. 100:100 given. Which one is the limiting reagent? Yash, Goel correct. Kartike correct. Tanu correct. Amir, yes. Kavish, yes. Basically, I am just looking for one wrong answer. Lemuel correct. Devansh, no. Arna, no. Arjun correct. Sankiti, no. Pratham correct. Devansh, no. Samad, no. Sabya, no. Devanshi, yeah. This is something I was looking for, okay? Which is the wrong answer. Don't say both are limiting reagent. Both can never be limiting reagent, okay? Because they have completed the reaction and none is left. Limiting reagent will be in that case in case one is left and other one is present. Okay. If both are consumed completely, it means yes, we got the reaction completed as per our expectations. There is no limiting reagent. So none in this case, because Q by R ratio will be 100 by 1, 100 by 1, same. None in this case. Next, tell me, and I am not going to write the reaction now. You need to tell me 5 moles of A and 2.5 moles of B2. Yes, Goel, yes, correct. Kartike, Vedant, Lemuel, Samad, Devansh, Tanishi, Arjun, Sabya, Arna, Kshitij, Jack Sharma, Shashwat, correct. Atman, think again. Kavish, Ariman, Ayush, correct. Devyansh, think again. Yashpedi, correct. This is given in the question. These are given in the question. So A plus P2 required 1 mole, 1 mole. In question, 5 moles, 2.5 moles. Q by R, 5 by 1, 2.5 by 1. B2 is limiting reagent. Okay. Next, 2.5 moles of A, 5 moles of B2. Yes, Lemuel, Vedant, Kavesh, Kartike, Amir, Pratyush, Devyansh, Devanshi, Savya, Tanu, Atman, Shashwat, Kshitij, Samad. Correct. All correct. Okay. So in this case, A plus B2 required 1:1. In question 2.55 Q by R 2.5 by 1 5 by 1. This is less. A is the limiting reagent. So it means in this case B2, in this case A, in this case none, then B2, then A. That is the answer, correct. Okay. In NCRT question, it's slightly different. So make sure that when you do NCRT question, you follow the rules and you will get the correct answer. Any confusion here? Anyone?
No, sir.
No, sir.
Good, very good. So I'll stop it here and we will continue with these questions and more questions of higher level in next class. Till then, take care. Good night. Bye-bye.
Thank you,
Thank you,
sir.
Thank you,
sir.
sir.
Thank you,
Thank you,
sir.
sir.
Bye.
Thank you,
Yes,
sir.
sir.
Yes, sir.
Thank you,
Thank you,
sir.
sir.
Bye.